All right, today we're going to factor a 4-term polynomial by grouping. It gets worse in factoring. I don't think this is as bad as some of the other things we've done. When there are 4 terms, you should always look for greatest common factor. Anything go in all those? No. So then what we're going to do is we're going to split it down the middle, have it 2 and 2, and we're going to factor out a greatest common factor of each side. So on the left, 4n to the third and 8n to the second. They both have at least n to the second. And then if you're looking at the numbers 4 and 8, I know that 4 goes in there. So we're going to factor out 4n to the second. And we're thinking in our head, 4n to the second times what gives me 4n to the third? Well, that's just times n. And then 4n squared times something gives me positive 8n squared. That's positive 2. Look at that. We've done the heavy lifting. Now here's something I will say. Anytime your lead coefficient, your first number, is negative, you have to factor out a negative. So this negative 5n, boop, I'm taking out a negative. What goes into 5n and 10? 5. So we factored out a negative 5. Negative 5 times n is negative 5n. And negative 5 times positive 2 is negative 10. Now again, look at what's in parentheses. N plus 2 times n plus 2. Ooh, same thing. That's good. So that becomes one of our final sets of parentheses, n plus 2. The other set is what we factored out, the 4n squared minus 5. Now, if you had the n plus 2 first, it doesn't matter. Usually you would see the n squareds in the first parentheses, but it doesn't matter. Here's the one other thing to check for. By the way, that's the final answer. But sometimes you might get it factored out to where it's like 4x squared minus 9 times x plus 3. The one thing you have to check for is if you have a difference of squares left. Like 4x squared minus 9, you could square root both of those. So that would be the 2x plus 3 times 2x minus 3. And then you would bring down this x plus 3 because we didn't do anything with that. But that could happen as well. But it didn't happen here. That's just one thing you got to look out for in the end. So here we go. A and B. Always look for greatest common factor. There isn't one. So then we just start going, all right, let's split it down the middle here and see what we got. On the left side, 5t to the fourth plus 20t to the third. I see they both have 5t to the third that we can factor out. When we do that, 5t to the third times t will give us the 5t to the fourth. And 5t to the third times 4 would give me the 20t to the third. On the right side, 6t plus 24. 6 is what they have in common. When you factor that out, you're left with t plus 4. They both have t plus 4 in parentheses. That's a good sign. So one of the final sets is 5t to the third plus 6. The other one would be the t plus 4. Check for a difference of squares. Automatically here, look, that's a cube, so it's not a difference of squares, and it has plus. It would have to be a square, and it would have to be a minus for you to go any further with that. These don't have a common factor, so we split it. On the left side, I see they both have w squared, so we factor out w squared. We're left with 2w plus 1. You got to put the 1 there. On the right side, I see it starts with minus, so we'll factor out a negative. 14w and 7 have a 7 in common, which again leaves us with 2w plus 1, which we want. We want it to be the same thing. So we have w squared minus 7, and we have the 2w plus 1. Double check if we have a difference of squares. I could square root w squared, but I can't square root 7, so we'd be all done at that point. All right, 2 more. These ones do have a common factor. If you look at all of these terms, they're all even, so I know that 2 goes into all of them, and they all have at least p to the first power. So we're going to factor out 2p. So if you need 2p, oh, I don't know how I do it. Once we divide these all by 2p, we'd have 6p to the third plus 5p to the second minus 18p to the first minus 15. Remember that 2p kind of hangs out until the end. You just can't forget about it. Then we're going to go ahead and split these four terms right down the middle. And I'm thinking 6p to the third, 5p to the second. The only thing they have in common is p to the second. If we're like p to the second times what gives me 6p to the third, that would be 6p. And p squared times 5 gives you 5p squared. On the right side, I see it starts with negative. I'm taking out a negative. 18 and 15 both have a 3 in common. If we divide them both by negative 3, we'd have 6p plus 5. Oh my gosh, that's the same thing as the other set of parentheses. So we had the 2p on the outside from earlier. Here we have p squared minus 3. We would want to check if that's difference of squares, but you can't square root 3. And then the other one would be the 6p plus 5. One more problem. Oh, you're so sad. We're almost done by factoring by grouping for the notes. Look for a common factor. All of those have 3m in common. When we factor out 3m, we're left with 15m to the third minus 3m to the second plus 10m minus 2. The 3m, I'm not going to forget about it. I won't write it yet, but I will not forget. We'll go ahead and split this down the middle. 15m to the third, 3m to the second. They have a common factor of 3m to the second. So we'll take that out. 3m squared times 5m is 15m to the third, and 3m squared times negative 1 is negative 3m squared. On the right side, only common factor is 2, which again leaves us with 5m minus 1. Great, that's the first set of parentheses too. So we have 3m squared plus 2, right? We get that from out here. And then we have the 5m minus 1. And luckily I didn't forget anything else. Factoring is so much fun. I hope factoring's never done.